we have managed on our previous video to create and utilize a class. However, there are some functionalities that needed to be improved. For example, the creation of the methods are done in a way that it is a overload of all of the variables needed to insert on this view. Right now, we'll be using a technique called unified modeling language to make our class more documented. Right now, if we look at our class, we have a different methods and variables being declared. The class person has a what we call variable which has the ID, having a data type of text box, L name to be a text box, F name to be a text box, and M name and other attribute are declared as a text box. If you observe, there's a minus sign on this class or on this variable because it says that it is a simple use on modified UML wherein it declares this variable to be private on the class. So meaning it cannot be accessible on a different class being created on our C# program. However, on the other functionalities of this UML, we can create at the topmost would be the name of the person and the variables, and then later on you declare all of the functions and methods being created. The functions and methods being created is different from the previous video that we have created. This is the improved version of the class. So first we have created a constructor. So what are what we call constructors? Constructors are what we call the functionality in creating a class wherein you want to run a certain line of code at the initialization time of a class. Later on, we can see how does this functionality works. We have two constructors. The first constructor requires no parameter, and the other constructor requires us four parameters, which is the L name, F name, text box, L name, F name, M name, and the address. This shows that this data being used as parameters will be assigned to the different variables being declared here. Next, we have the clear data. This one represent the plus sign. All of them represent plus sign. And then open and close parenthesis shows a colon saying it is a void. So what do you mean by void? It is a method that does not return anything. So if you look at all of those things, all of the methods having what we call the keyword void, it says that this does not return anything when you are calling it. On the other side, we have the check data that we have what we call a colon and then a data type. This method requires us to return a Boolean operation or Boolean variable which has a variable of true or false. Remember that our check data just checks whether the data being inserted is already existing on our list view list. So now, let me show you the actual code being created. The code being created right now, if you look at the declaration of the text box, it is already declared in a manner that it is done on the UML. So what transpire on it is that on what would be the arrangement and what would be the sequence of the declaration of the variable should reflect on your UML. Next is our constructor. We have the public person, which is no parameters, and then public person having a lot of parameters, which is the L name, F name, and M name. If you go back to our UML, here are the constructor being created, and here are the variables being created. Take note, the person is the same as the name of the class. If the name of the class, when creating a constructor, the name of this should reflect the name of the class. So this is the way you declare a constructor. Then if you look at all of the codes, the sequence of creation of the actual method and functions are done in a way that it is arranged on our UML. So that's what we call, that's how we constructed our class. Now, what we want to accomplish today is to create a certain functionality on utilizing a class which has what we call a functionality in a manner that a class inherits from another class. When we say inherit, all of those variables and functions that are declared in a public manner can be accessed on the child class. I think even though it is private, it can also be accessible when you are inheriting it. So how do we create an inheritance application of a certain class? To further assess or to further implement or to give you a demonstration, we'll be using two different class. We have what we call the teacher and the student. If you look at the actual arrangement, we can say that a teacher is considered also as a person. Now, how do we integrate this data? Take note, when we are talking about inheritance from a generic point of view, that would be the main class. So all of the common data on a certain scenario or certain given data from the situation, it will be putted on the person. So you look at the common, all of those common data that they have, and put it on the main or the parent class. Now, if you create a child, you need to be specific. What are the data that are specific to that child class? Now, for example, if we create another class, okay, so if we create another class, we can consider that we have already created another hierarchy for that class. So now we will be creating a class which is what we call the teacher. So the teacher represents on what are the data that are unique to a teacher. For example, a teacher has what we call the license number. A teacher has a subject being taught, and then a teacher has what we call a rank or the academic rank, and a teacher might considered as what we call an advisor. But this data, we will only consider the following data. Later on, you'll be the one to put what are the data being created or what are the data that you might consider which is unique to a teacher. So, for example, we have what we call license number. Next, for example, we will be adding another attribute or property. What would be the rank of the teacher rank, or let's say position, current position. Okay, and then we will be having what we call the affiliation of the teacher. So where the teacher is affiliated, or what company or school a teacher is already deployed. Okay, so next is what we consider, for example, we want to add what we call the methods for the teacher. So the methods for the teacher would be you want to add the different details of the teacher. For example, we want to add the name, the data, which is the license, current position, and affiliation. So we can consider doing this one. We add a operation, or another is we create first the constructor. So the constructor for this one is the teacher. Okay, so take note, if we create a constructor, the name of the teacher will reflect the data being reflected on a constructor should be the name of the class. So we add a operation. So right now we need to change it to teacher, and then we can say that there is a property for this one. We can change to stereotype, then create. So we have the constructor, which is an empty, and then we can add another constructor, which is another is teacher, having a attribute parameter, which is the license number, current position, and affiliation. So okay, then we put the actual other methods for the add teacher. So we put the name of the teacher on a list view. Okay, so we'll be adding it on a list view. So okay, let's have some changes here because I forgot to put the data type. Okay, so suppose that we want to have, okay, I'll just remove this one. License number is what we call string. This would be the data type. Okay, position is a string, and then affiliation is string. Now if you look at this one, so we have teacher, and then we remove this one, then we add a operation, then change this one into teacher, then we add a parameter, all of the parameters. So you look at the string is already there, and then I think we have made our constructor for the teacher. Okay, so with 3 parameters. So now the next part is to identify on what are the methods for this class teacher. So if I add a method, we can say that we want to add those data on a list view. So add teacher. Okay, and then we put those data here. Okay, so what are the add teachers? So we put just LV as the container, and then the teacher, the list view. So then we add another is to add more position, add teacher, and then delete teacher. Take note, I'll just make this one as a void because this one does not need to return anything. Now, so that is our method for this teacher. So suppose if you want to add more method later on, you explore it. So the teacher, take note, we have minus sign for the private and plus sign for public. So take note, if you have made or managed to make it private, it cannot be accessed, it will not be accessible to the different classes being created. But if you make it as a public, it will show you, it will interpreted as a public through all of the class or through all of the files being created on your program. So now next is for our student. So I'll just create another student. Okay, so we have another class which is a student. Okay, student. Okay, so we put what we call the name of the student is already on the person, and then we add another variable, for example student number. So let's say it is an integer, and then we add more data on it, which is, for example, subject. And what are the subject? Let's say year and section. Year is equal to integer, and then we add more section. Okay, student section. So we put it as string. Now we create a constructor, parameterized constructor. First is we create a empty constructor, which is the student, and then we add more constructor, which is all of the data of the student. So then we assign it again here. We assign it again as a method to add a student. Okay, so create another method, add student. So you will be requiring them to put what we call the student. Okay, so first is we put the list view, lvn list view. So that is what we call our class. We have managed to create 3 classes, and these 3 classes represents the entirety of a person. So take note, we have not yet created any functionality or any collection within person. So let's make it and do it on our C# program. So first is the teacher. Let's do the teacher. So I will be going to my solution on the class, and then what I'll be doing is to add new class. So we will be having what we call the teacher. So the teacher represents what are the data from the teacher. So the teacher have what we call license number, current position, and affiliation. Okay, so we create string license number equal to empty, and then we can create another data, license number, and then we have its current position and its current affiliation. Then we create a constructor, public teacher. Then we put no parameter. The next one is public teacher having a parameter. Okay, so there we have managed to do that. So we put the license number to the license number. We have already managed to do the data for the teacher. Then we create a method to store the data of a teacher. Add teacher. That requires us to send a parameter which is a list view. Okay, so now add teacher. Okay, so it says we have void. So now this is the class representation of our code for the teacher. So we managed to create a teacher, and then at the same time we have managed to put what are the variables and methods needed for the teacher. Take note, there is no functionality here yet. We are just creating the actual class based on the UML that we have designed. So now the next part is on the student. So we go we create another class. Okay, we create another class which is what? Student. So the student has a different variables. Student number. Okay, so first is int student number. Okay, I think student number, which is equal to 0. Then we have what we call the year, which is an integer. Okay, here int year, and then last is what we call the section. Okay, so string which is the section. Okay, there you go. We have declared the different variables being needed. Now we create another constructor for the student. Okay, so public student, then we put which is the empty one. Then we create another constructor having the parameters public student having the parameters. Okay, so there we have managed to create the student, and then lastly we put public student. Okay, public student, and then what would be the things we want to add student, rather public void add student. Okay, so on the add student we just put list view, the name of the list view where we want to put the actual data there. So we have managed to create the three classes: the teacher, person, and student. Though if you look at, for example, we want to create a certain instantiation of the class. Okay, what will happen is that we can access the class, but we are not able to access the actual person. Okay, so let's see what will happen. Okay, so for example here, right now we have person, but we can still create a student variable that holds the class student. So now here you look at student, what are the data which are in public, which is the add student. We get the add student. Okay, we have the add student. Then that's all we can use, because we have not inherited anything on the class person. Same with the teacher. If we create a instantiation of the teacher, you look at the teacher, there's only one method or variable that you can see: add teacher. So we have already created add teacher. How about if you look at the hierarchy that we want to do, is that this data being created should be dependent on the actual person, because every teacher has a name and every teacher has what we call a connection from the actual person, which is the person, and those data should be connected to the person class. So what I mean is that all of the teacher are considered as person. They have what we call the last name, first name, middle name, and address. And all of the student also have last name, middle name, and address. Now, if we have what we call the composition or the inheritance, we use this kind of arrow on UML. It says that we are inheriting the person data on teacher. So it's like we don't need to instantiate person anymore, but rather we instantiate teacher, and automatically all of those data from the person would be accessible through the teacher. So what would be the keyword that we'll be using on the C# program? So I'll be going to the student. Then in order for us to inherit person, we use the colon sign on a class, student colon, and what class do you want to inherit? So right now we want to inherit to person. So student to person. So if you go now to our code, okay, if you go to our code and we type the actual code that we have created previously, you can observe that when we press student, okay, that it will now show you the save data, check data, edit data, and other functionality that are inside to the person. So it's already on the person. It's not now on the side of the person, but rather we can now extend on what are the data that we have created. So same with the student, teacher will be doing that one because a teacher is a person. So we create teacher to extend to person. Now the question is, how do we initialize the variables that we have created here? If we are not using inheritance, okay, if we are not using inheritance, we can use it through a constructor. Okay, so but let's see if we can manage to do this functionality in a way that we just declare this data to be public. So I'll be going to the person, and then I'll be doing this one as public. So now public lname, fname, and address. So we can now change this data and manage to assign on what are the data being needed to run the actual application. Okay, so we have managed to create all of the variables to be public, but we can do another way so that we can assign some data on the person without making all of the variables to be public. So right now we can access this one on a student class that we have instantiated on our program. So I'll go to the class here. So we have, if I press std.lastName, we have already managed to access lname from person through the use of student. And then we can now assign text box fname, so txt fname to be our first last name, or we can rather txtl as our variable. We can do this one, so like that. And then std.mname, okay, mname is equal to txt mname dot text mname rather, and then std dot address, okay, is equal to txt address, and then txt fname std dot fname is equal to txt f. Okay, then after that we can now create or call the function std.add or save data. Take note, save data is listed on the person, not on the student. That is the advantage of using the inheritance. So now we can now put the actual student actual list view, which is lb person. Okay, so now if you will be running the program, if you run the actual program, okay, so just go to the program cs, change this one, lb forms. So if you run the program, even though the data that we are inserting is student, it will now save it on our list view, because recall we have inherited all of those functionality from the person. Okay, so now let's see what will happen. So for example, the name of the student is Tolenada Aaron James. then the address, then I press save. So what will happen is it will add this data on our this view. So let's check first. I think we have an error. Okay, let's see. Save data. Oh, this one. Because we have saved data here, I'll just comment this one first. Then we call clear data for steady. So that we clear all of the text box. So now if we run this one, okay, so even though we are accessing the actual application or the actual saved data on the student, we have managed to inherit the saved data from person using the student. Okay, so you see, we have already managed to do the data, put the data. But for example, on our teacher, if you want to do that, we can also do this following functionality. So we put this teacher, and then what are the data to put on the teacher will be creating or using this teacher class instead of using the student. So if we go to this one, okay, we go here, so you can see even on the teacher we can now access LName because we inherited all of those data from the person. Okay, here are the data or the text box, but take note, we need to put it as a public so that we can access it. But then all of the methods here that are declared as public are now what we call a can now be accessible on the different class that we have created through instantiation or through inheritance. So right now we have created or managed to create one instance of a teacher and one instance of a student. So if we run this one again, okay, so regardless if it is a student or a teacher, so for example, we put a data here. Okay, so we have the data here, so the student had been inserted. Okay, so now we can put another way. We comment the code here for the LB form so that you can see that the student is, or the teacher is already being utilized. Okay, see, so teacher, so there you go, we have managed to create the student and teacher class. In summary, if we want to create an application to be documented or well documented, you need to use a UML, Unified Modeling Language. This will help not only the programmer, but also the transition from one programmer to another so that they can easily navigate or to easily understand how those data being utilized, on how those class being utilized, what are the methods that are common to the teacher or to the subchild of a class, in order for you to make it more efficient on coding or learning the codes being turned over to you. So without the UML, it's hard for you to understand on how does this codes run. So it is a best practice for you to create UML before creating the actual class. This will give you a blueprint of the entirety of your program. So I think that's all. So happy coding.